get this started. All right, everyone. Welcome back. It is Monday, a brand new week of class, but we're going to start looking a little bit at what we did last week and building on it a little bit before we move on to the next section. In the next section, we'll be looking at how things tie together a little bit more, as well as introducing some ways that our server can render what our HTML is going to be. We've seen some of that, but we're going to look at some more advanced techniques for doing that. That's going to look a little bit at React, or not, the way it's going to be similar to the way React does it. It'll make it a little bit easier when we finally do change over into React for that to work. So I want to review a little bit from last time. So go ahead and open up. We're going to go back in time a little bit. Books.sql. So using this file, in your groups, you're going to answer the following questions. So using this as a reference. Starting at the database server level, what are the different levels of organization in a DB? So what different levels is the structure in our database? What are the different parts of it that we learned? Another one is going to be how many tables are created here? What does auto increment do? What is a primary key? What does CRUD stand for? Which parts of CRUD do the different files, or do the different commands map to? And then lastly, as you scroll towards the bottom, you're going to see that we have joins. And what we want you to do is try running this. Can you identify what the different join statements are doing? So this is going to function a little bit as a review. A lot of it's analysis, and then we want you to run it, and then run just this piece by itself, run this piece by itself, run this piece by itself, and try and identify what's it doing. What's it doing? So actually, let me add in one more thing here. What is varchar, and what does the number after it mean? There we go. So I'm going to have us open up the breakout rooms. I'm going to post these questions in class activities. Use O5, booksdb, books.sql to answer these. So I'll put that up at the top. O5. Alrighty, so I'm going to go ahead and post this in class activities. All right, and what I want you to do is in your groups, answer these questions. You can answer them together. Make sure that you can run it in your SQL Workbench. If you can't, let us know. This will make it easy for us to identify if any problems have popped up over the weekend. And we'll be working on this for the next 15 minutes. If you have any questions, let us know. We'd be more than happy to help. Good luck. All right, folks, welcome back. We're going to still wait for just a few people to pop back in here, but we have this schema file to work with. It's just kind of an example for different pieces. And so I wanted to start out with the first question we got here once everyone gets back. So be ready to share your answers as we go through each one of these and then talk about this. I'm going to start by just copying this whole thing into my workbench. And we could run it. It's basically, at the end of it, a bunch of select statements. And we'll take a look at those more individually in just a second. It looks like everyone's back. So let's talk about the different levels of organization in a DB. The first topmost level one is the server. Inside of our server, we have what?
Database.
Databases. Which commands over here are related to modifying things at this level? Which commands on the left here?
Create table.
Yeah. We've got, well, that isn't modifying stuff at this level. Within that level, yes, and we'll get to that. But I'm referring more to these three. This is where we get rid of databases, create them, etc. You could even alter databases in certain ways. We're not talking much about permissions in this use case, but a lot of times you would also have database users that only have a certain level of permissions. Throughout this course, we're just going to be using root. But if you're interested in databases more, you would want to have things that only have certain access to set up those kind of things. And a lot of times, as if you get into that side of things a little bit more, you'd learn more about those different pieces. We're just here to give you enough to get you moving forward. During application development, you usually don't have to think about that a lot. It's less of an application developer thing and more of a DevOps thing to manage permissions and all of that kind of stuff. Doesn't mean you won't do it, just means that it's not emphasized in this course. Cool. Underneath databases, what do we have? Tables. Which commands affect things at this level?
Create table.
Create table. This will make new tables. And they're also affecting the layer beneath it, which is what?
Rows.
I would say columns more. You have to have columns before you can have rows. If you don't have columns, you don't know how to fill it in with rows. So it's good to think about these in kind of the order of which you have to have first in order to have more of them. If you don't have any columns or tables, you can't have any rows. These are kind of a package deal. These kind of exist at the same level. A table is just built out of columns, but you can't have columns without a table or a table without columns. So these two kind of go together. You might add or remove more along the way, but they're kind of at the same level. And then lastly, we have rows. And our rows are being modified here. So what are the other commands that can modify rows? Or the number of rows?
Delete, insert, update, or not update.
Update, yeah. So what is varchar and what does the number after it mean?
Varchars make a string. The number after it is how many characters can be in the string.
Mm-hmm. What does auto increment do?
Increases each insertion by the factor of 1. Right?
Mm-hmm. Yeah, so this means that the database is going to take care of populating this number for us. It starts at 1 and then works its way up. There's ways around that, but we won't be using those. Next, what is a primary key?
Your main identifier.
Yeah, it's the main identifier for the table. It's going to be how other tables primarily referred to you. Because it has indexes built up, which we talk about more. But most of the time, that's going to be your ID. But your primary key is going to be how other tables reference each other, which we'll see when we come down into books and authors. What does CRUD stand for?
Create, remove, update,
Create, read, update, and delete. And when we're talking about this, we're almost always talking about rows and not the higher levels of organization. We're thinking about these in terms of new rows viewing existing rows, modifying existing rows, and removing existing rows. And we use the acronym CRUD to do that. And we already kind of mentioned some of the other parts. Create is insert into, read is select from, update, not mentioned here, but it would be update table set value where equals something. And then we've got delete, also not pictured here, where you would say delete from table where criteria, etc. In fact, if you'll use the what's called the where clause quite a bit. This is filter the rows the operation will apply to. Now, all of the CRUD actions use where except one. And which one would that be?
Create.
Create is the only one where you won't really see where. When you're reading stuff, you'll have where. When you're updating stuff, especially, you'll have where. And deleting stuff, oh boy, you better have where. If you don't want to get rid of all of your data. Cool. Then we had the joins, and that's when we see these different pieces down here. So what do joins do? Any ideas?
Join two tables or multiple tables with each other.
Yeah. So we can see that we have two tables listed here, books and authors. And then with the on criteria, we see that the author ID is related to the author's ID. So this is how the books table refers to an author's table. So in this case, we can see that Pride and Prejudice and Emma were written by whoever has an ID of 1. Now, this seed file was written knowing the order, so that's going to be Jane Austen in this particular case. Same thing with Tom Sawyer, Huckleberry Finn. Those are both written by Mark Twain. Alice's Adventure in Wonderland was written by Lewis Carroll. And you'll also notice that under authors, we have Andre Asselin, who doesn't have any books in our database. And then we've got Dracula, who we don't have an author for that in our database, so we've listed that as null. So in our case, because the author ID didn't have to be not null, it's quite possible to have a book, we don't know who the author is, or they're not in the database. And then it's quite possible as well to have authors with no books. These are going to be our sort of extraneous cases. Now, let's go ahead and run this piece in our database after I've run the rest of it. Who's missing from this list? If you run this in your workbench, who's missing and what books are missing?
Andre is missing and Dracula is missing.
Andre is missing and Dracula is missing. Excellent. So what inner join does is inner join, if we look at author ID and authors.id, says that these both have to exist. You have to have when you're putting these two together, it has to have an entry for both the books.author.id and for the authors.id. So when a join happens, what it does is it takes the left book and it takes the left table called books. In this case, it's what is ever to the left of the blank join statement. It takes a look at the right one, in this case, authors, and then it says, where can I find matches and how does it match them together? Where the books the book's author ID and the author's ID match. So it says, hey, when these two are together, it's the same. Now, if I have a book without an author, inner join says don't include it. If I have an author with no book, then I don't include it. And so this is very, very common for working with data sets. Let's go ahead and look at the left join and see how it's different than inner join. Left joins are also ones you'll see a decent amount of the time. So first of all, when we run this, or before we run this, which table is on the left, so to speak?
Books.
Books, because it becomes before the join statement. The only difference between a left join and a right join is you could just flip the order. It's just which table do I defer to. Now let's take a look at this. Are any of our books missing?
No.
Are any of our authors missing?
Yes.
Yes. So what would we say is the rule for this one?
Whatever is left, no matter what, they're going to show that.
So we look on the left and we see, hey, is there anything that matches up with books? Is there anything that matches up with those books? And then we're going to opportunistically add the author's ID. So because of that, you'll notice that, hey, we've got Jane Austen in here multiple times because Jane Austen matches up with Pride and Prejudice. Emma matches up with Jane Austen as well. Mark Twain matches up with Tom Sawyer and Huckleberry Finn. Lewis Carroll matches up with Alice's Adventures in Wonderland. And Dracula, we said left join, so we are going to have the books no matter what, but we're going to have null for the other categories because we don't have an ID to match it against. And that person's not in the database. Cool. Now, if I change this to be right join, let's see what happens. So how is this different than left join? What's been added and what's been removed?
The book is not there and the author is.
Yeah, so we are missing Dracula at this point. And we've got Andre Aslin here. So in this case, we start out with our authors. And we say, hey, all the authors are guaranteed to be here. So Jane Austen is here. And then it says, hey, let's match up. Are there any books with your author ID? Yes, Pride and Prejudice. Yes, Emma. You'll notice that we're repeating the authors each time here. And then Andre, even though he hasn't written anything, because we're right joining and authors is on the right, it's going to put that in there. Now with these, right here, we've got title, first name, and last name. The longer names for this would be books.title and authors.first name and authors.last name. And sometimes you will need to use the long form when the two tables have names that overlap. When the two tables have names that overlap. So having those two match up could be, sometimes I'm trying to think of an example. So let's say that you have a system for purchases for your online store and you have an account table and an order table, and the account table has a name associated with it, and the order also has a name associated with it. You might have to differentiate between the two. In fact, I think we'll see some examples in the future. But that's essentially how joins work. We'll be using those later today. Any questions about joins? Alrighty. So with that, we're going to dive into some of the exercises for today. We're going to start at number 12. Number 12, this top 5,000 schema. Inside of this, we have the two files, topsongs.csv and top1000songs.csv. Topsongs.csv could also be named top5000songs.csv. And this is just a more limited subset. We provide the two to you in case your computer chugs a little bit on 5,000 rows, importing all of that data. We provide a smaller one in case your computer is affected. These are in CSV files. CSV stands for comma separated value. And so what that means is that this is one value, and then Bing Crosby is one value, and then White Christmas is one value, 1942. And then we've got a number of other numbers after that. So let's close this one out. And you'll notice we have just new lines for each one. So this first one is its ranking and best-selling songs of all time. So Bing Crosby's White Christmas, according to this. I don't remember what year this is from. And this is obviously English-centric songs. White Christmas from 1942 has a lot of sales. Anyone want to guess what this one is?
At 39,903.
I think it's million, but 30, and this is the total sales. And then it's broken up into different regions. So the first region, anyone want to guess?
America.
United States. And then second region, anyone want to guess?
Europe.
Europe.
The UK specifically. The UK specifically. After that, it's the rest of Europe, and then the rest of the world. And it's fun to look at this because look at Bing Crosby, you can see it's very America, British-centric. And then you look at My Heart Will Go On, comparatively, and you can see that, sure, you got America and the UK like it, but the rest of Europe likes it a whole lot more. Likes it a whole lot more. And then comparatively, the rest of the world likes it better than Bing Crosby, about 6 times as much. So, well, 7 really. So this makes it fun to be able to look at these pieces of data. And if we look here, we can see, man, there's a lot of data in here. I'm not going to scroll all the way to the bottom, but there's 5,000 rows within that. So this is going to be our data set that we get to work with. So the first thing that we need to do is we need to figure out what should the schema be for this. What should the schema be for this? So I'm going to go ahead and provide some of that for us, just to keep us consistent and like, hey, what's the name, etc. But let's build this together. So we'll set the drop database if exists, top underscore songs DB, create database top songs DB, use top songs DB, and let's call this table for the sake of staying consistent with the exercise and the documentation, we'll call it top 5,000. Now, what, and I might do some light renaming just to keep it in track with the solution. But our first one is going to be the position on the chart. What data type should it be?
Integer.
It's going to be an integer. Should it be mandatory?
Yes.
Yeah, I think having that be mandatory is pretty good. So if you're in the top 5,000, we need to know which of the top 5,000 you are. Anything else about it?
Auto increment.
Well, we don't want to do auto increment because we're importing the data. We don't want the database to kind of keep track of that for us. But you're hitting on something else, which is that we want it to be our primary key. This is going to uniquely identify stuff. It's possible for songs to have the same name. It's possible definitely possible to see the same artist in here multiple times. And the sales numbers certainly aren't going to be great unique identifiers, so we're going to use the position to do it. This is a case where you might not see an ID associated with stuff. When we make our own tables, we're probably going to include that. But in this case, here's a non-ID primary key. They do exist. You just don't see them as much typically. And usually it's because you're looking at some sort of positioning information within it. Cool. Next one. We've got
Artists.
the artist. And what data type is it going to be?
Varchar.
Varchar. And let's say 100, let's be generous. And technically, none of the rest of these are mandatory. In fact, the solution has them marked as null. They just happen to all be present in our data. But you might also, designing the DB, decide, no, you should have the artist. For this, I would argue that the song should be not null, and the others I could see, depending on your data set, leaving empty. But at least the song should be, because it's a list of songs. And if you don't have the song, why is it in your database? Versus the artist, you might be like, well, it's a folk song or something like that. We don't know how to attribute it exactly, or maybe it's in contention and we don't want to come out on one side or another, so we're just going to leave it null. But the song itself is probably the one I would say as that, which is kind of our next one.
Does it default to null if it's not stated in there?
Yeah, if we don't provide one for it, it would be null. Now, in this case, our data set's complete, so it doesn't much matter which one of these we choose to be null or not null, but the important thing is to say, okay, which of these am I deciding will be in a particular way? And we want to lay these out in the same order we get, as it'll make the import process earlier for us. So we'll declare them to be in the same order. Next, we've got a year, which is again going to be an int. Then we're going to have some sales numbers. And because real world data is sometimes messy, you'll notice that the last four numbers do not always add up to the total. That can be messy because counting music sales is a surprisingly complicated process. What counts as a sale, other things like that. So and getting the reporting correct means that the numbers won't always necessarily add up correctly. So we're just keeping this raw total as kind of a metric for we're pretty sure it's this, accounting for errors, but our individual reports aren't necessarily going to add up to them all the time. And that's true of real world data as well. Now, in this case, we can't use an integer because we're working with numbers that are smaller than that. So we have this raw total. Let's go ahead and then set the decimal. The first number is going to be the display number, kind of like an integer. And then the second number is going to be how many decimal places we keep track of. In this case, 4. All of our numbers have 3 or less, so 4 feels pretty comfortable to us. That even gives us enough room for an extra bit of margin in there. It's been too long since I've had to think about significant digits, so I don't remember the rules there, but I think we're good. So next, let's go say null, and then we'll just do this for each one of them. We had the raw United States numbers, so we'll say USA, the UK, Europe, the rest of Europe specifically, and then the rest of the world, as they tend to make up a statistically relatively small sample set of our data here. And again, this is a primarily English-speaking song. Guess what? There's a bunch of songs out there in languages besides English that do pretty well too, but these are all going to be English songs that you probably recognize or don't recognize. Like, especially once you get into the smaller ones, like, well, That's a problem. I still see like, hey, Billy Joel, Uptown Girl. I'm like, I know that one. Just jam into it in my head. That's some of the perils of going through this. Is it's easy to distract myself with that. So we're going to create this table. We'll put a semicolon at the end. And then if we just say select star from top 5,000, that would just mean we have it empty. So I'm going to go ahead and post this in the class activities channel. Go ahead and run this in your own workbench. And this will just help keep us on the same page going forward. So this is our top 5,000 tables. Oh, I made a mistake. Don't use that one. Hold on, abort. I put curly braces where parentheses should be. So let me get rid of that one and the Slack channel. And let me add in this one. There we go. Much better. Please use the one I have posted now. So let's go ahead and run this in the workbench. Oh, and I forgot a comment in there. Oh, I'm batting 1,000 today, y'all. I should probably run this first and then check. Have posted it, but all right. Should be updated at this point. Should work. Let's run it to make sure. Excellent. Cool. Any questions on translating from this to this? By the way, if y'all haven't seen the YouTube video of LMFAO dancing to Uptown Girl, it's pretty good. It's pretty good. So let's actually get this data into our program. Let's actually load all of this CSV data into our database so that we can now make queries against it, run selects against it, try and determine some neat or different information using this data. To do that, we have to actually have everything be in there. So I'm going to refresh my schema right here. Tables, top 5,000. I'm going to right click on this and I'm going to click Table Data Import Wizard. You can also do that on, I think you can do database. It's up here as well. I just forget exactly where it is because I always use the right click menu here. But you right click on it, Table Data Import Wizard. You can also click on it from one of these rows. I'm trying to remember which. So, Table Data Import Wizard. Now, we need to pick the file that we're importing from. So we're going to browse. And I've got this one right here. I'm going to just pick the top songs in the top 5,000 schema, unsolved, top songs. Let's go ahead and click open. Let's click next. I want to use my existing top 5,000 table. You could create a new table if you wanted to based off of that, but sometimes that will include extra things. So we just explicitly created this table. Next, we want to make sure that everything lines up. So 1 matches with position, check. Bing Crosby is the artist, White Christmas is the song, 1942 is the year, etc., etc. So seems correct. Let's go ahead and click next. We're going to click next. It's going to take some time to import the data. If for some reason your computer is chugging with 5,000 entries, you can use the 1,000 entry file so that it's a little bit less work for your machine. We'll be doing this again later when we're working with different albums. What I would encourage you to do is at this point, comment these lines out so that you don't accidentally delete your database by dropping your database and running it again. So just select these. Once this is done, it's going to take a little bit of time. And then just comment it out.
And that's for the drop and create, but we still want to have the use top songs DB.
Yeah, you still want to have the use top songs DB, but we're going to get rid of comment out, drop database, create database, and create table. So these, so that way it still knows, hey, use the top songs DB, but then the rest of our queries won't accidentally get rid of something. All right, so let's click next right here. 5,000 songs imported. Let's click finish. Let's go ahead and comment out those ones. You can still use the command / shortcut, which will still comment them out. And unfortunately, my computer's chugging a little bit at this point now too, so. Sometimes MySQL Workbench is like that. All right. To make sure that all of this has worked.
What's that shortcut for commenting it out?
Just command /, it's the same key as the question mark. So let's select this whole thing. Let's execute this query. And now we've got all of these entries in our result grid. Cool. When we run this in our result grid, the result grid is inherently just going to look at the first 1,000 because it doesn't want to display all 5,000 of them. So you imported it correctly. The results grid is just going to show you your first 1,000. It just limits it by default. If you want to work with other ranges, you can modify your query range up here. And I think it'll even let you go to the next one on there, but I forget exactly how to do that because most of the time I just limit the range I'm working with rather than having to scroll through thousands of them at a time. Oh, that looks great. All right, so what we want you to do is we're going to have you open up, make sure that you can do this. We're going to break everyone out into their breakout rooms. If you're having trouble, try asking each other for help. In the process, make sure you can run through this. So we're just going to take 10 minutes to do this really quick. We're just going to take 10 minutes to work on this, and then we're going to look at actually running some queries against it. We'll start with running the queries, and once you finish up with that, we'll look at saying, hey, can we actually write a node program around this using Inquirer to help us answer these questions as well. And then we'll take some time this afternoon to incorporate in working with multiple tables. So we're going to open up the breakout rooms for 10 minutes. If you have trouble running the imports, let us know. It takes a while, that's fine. But if it's taking, if it's getting towards the end of the 10 minutes and you're still a long way from importing it, let us know and we'll see if we can help you out in that scenario. All right, good luck. Alrighty, folks. So, hopefully none of you experienced any issues through the import process. If you did, we're going to use part of the time with this next assignment to help you if you did. Please reach out to us if you're running into issues. The import's taking too long. You weren't able to complete it, and it's just taking super long, or there was errors and you're not sure how to work with those. Let us know. We'd be more than happy to help you out. But we're going to move forward kind of assuming instruction-wise that all of that worked. So what we're going to be doing in this next exercise is we're going to be, if you look at 13 top 5,000 code, we're going to be trying to make some different items. We want you to write a couple of different queries that are going to try and retrieve a certain amount of information. And some of this is going to require research on your hand. We haven't covered all of these SQL commands in class, but these is often going to be the case when you're trying to do something with SQL. You're going to have to look things up and be like, hey, how do I do this? How do I do this? So we want to give you practice that. We'll definitely be going over these and explaining them in depth. But we want to sort of put this in front of you, give you something to work with, work towards along the way. So first one, a query which returns all data for songs sung by a specific artist. This is pretty similar to a query we would have written before, like when we were using songs by genre in the playlist exercise from last week. We want to have a query which returns all artists who appear within the top 5,000 more than once. That's going to involve you checking on whether they have appeared more than once. A query which returns all data contained within a specific range. This could be all the data from within a specific year. This could be data within, like, say, you want to do a countdown of the top 100, and you start out with, hey, I want to know 91 through 100 for my first blog post, 81 through 90 for my second blog post, etc. As you count down towards the top 10 and give a little blurb around each one, it would be a query that you would use for something like that. And then lastly, a query which returns for a specific song, and the top 5,000 returns the data for it. So you can search by title. How would you be able to search by title? So what I would say is, first off, in your groups, together, figure out what the queries are. Research those together to figure out, hey, what would the actual SQL statements be? Once that's done, try writing a node application where the user can start filling in some of this information. Like, hey, we want you to be able to choose the menu option. I want to look up songs sung by a specific artist, and I'd like to look up ones by Queen. I'd like to see all the artists who appear in the top 5,000 more than once. I'd like to look for the ones between position 5 and position 25. I'd like to look for a song by a specific title, etc., etc. But again, work on making the queries first. Get the queries for all of them done before you worry about the node application. Once you've got your queries in place, then you can start trying to write the node application if you still have time left. There's definitely some MySQL queries that can help make this easier, and there's going to be multiple ways. So if in your groups you discover multiple ways to do it, that's completely fine. There's not just one way to do some of these. For some of these, you're going to have to use specific techniques. Some of these are a little bit more open. And so this will require a little bit of research. We're going to be taking basically the rest of time before lunch to work on this, and we're going to be reviewing it after the fact. We're going to be cycling through the breakout rooms to check on you, see if there's any issues. If there are, if you run into them early, please let us know. We can start responding to you and even jumping into the room if it's a particularly difficult issue. So please let us know if you have any issues, and we'd be happy to help. Good luck. Alrighty, folks. Looks like we're piling back in from lunch. Hopefully you had a good lunch. I made myself a bagel with peanut butter and jelly, and I liked it quite a bit. So what we're going to be doing is just starting out by looking at the SQL queries. A lot of the things you want to do is think about, okay, what's the data? How am I going to access the data? And what inputs can the user give us to that data? So we're going to start with the data this time and start with the SQL queries, because the SQL queries are the new thing. A lot of times when you're working on a project, tackling the new things is important because it gives you an idea of how much risk there is involved in it. And you want to account for how much risk there might be as you tackle new projects and sort of tackle the risky stuff first. That way you can pivot if you need to, if the risk isn't working on in your favor and you have the most time to work with it. Cool. So let's start out with this one. We're going to look at the SQL statement that we need to query songs sung by a specific artist. Let's just say it's Queen. We're looking for songs sung by Queen. What would the SQL be for that?
These select all from top where oh yeah, where question mark.
Yeah, where, and then it would be, in this case, artist equals Queen, but we'll replace that later when we're building in the user input, because the user will be allowed to specify that. And we could say where artist equals question mark, or just where question mark. Either one would work. So first of all, after we've written our query, the first thing to do is to check to see that it works, which we do in our database down here. So let's go ahead and run it. And it looks like I have a problem in here. I bet I named my table incorrectly. No, that's correct. Let me make sure I'm using the top songs DB. Did I put like a colon instead of a semicolon? There we go. So as you can see, Queen, quite a few entries on the top 5,000. Who would have thought, right? The number one is Bohemian Rhapsody coming on at number 46. And they even have Bicycle Race on there, or We Will Rock You, and a whole bunch of other fun ones. So we've got that query done. Check. Let's move on to the next one. So we have a query which returns all artists who appear within the top 5,000 more than once. So this one's a little bit more intricate and definitely sort of outside of the scope of what we've covered before. So who wants to take a crack at it? So I'll start us off.
Select.
Yep.
So select an artist, and then count in parentheses with count in the parentheses, and in the parentheses star.
Mhm.
And then from top 5,000 grouped by artist, having, and all space having count, and then in parentheses star greater than 1.
All right, let's try it. So let's run this. And here's a list of artists, all of which you have how many times they appear on it. Let's go ahead, and one thing that we can do that's kind of nice is we can actually label this count as something. So let's just call that as artist count. Then we can say having artist count greater than 1. order by artist count descending. So in this case, this can be useful for finding, for example, who has appeared on our top 5,000 the most. That's Madonna. Tied in second place is Elvis Presley and the Beatles, followed by the Rolling Stones, and shortly behind Michael Jackson. After that, everyone else is in the 20s or below. But it's Madonna by a number of entries, by 5%. So that's like a 10% jump over anyone else. So Madonna, not necessarily in the top 5, but a consistent producer. So a good way to help you arrange all of this is to say, take select from whenever you see one of these keywords, you can just kind of make it a new line. Like so. So let's go through how this kind of works. The first thing that we do oftentimes is we think, hey, what's the table that we're going to use? So we might start out with select star from top 5,000. The next thing that we need to do is we need to group similar things together. So we say group by artist, and you might be asking, hey, why am I not using where? Where has to do with individual rows. So that would limit us if we wanted to select artists or songs that only met a certain criteria. So we could say like, hey, we could say where year is greater than, let's say, 1980. So this would then limit who could appear on the list a little bit. So let's go ahead and run this. So this would only group together artists that had existed after 1980. So you can see the Beatles got cut from this list, as well Elvis Presley got cut from this list. And that's selecting the individual rows to be involved with. Having lets us work off of the groups, because now everything is in this. The count works off of groups. It's going to say how many are in this group. That's where our artist count comes from. And then as is just a nice way to label it. And so having artist count greater than 1, in short, things that are, they've appeared more than once. And then the order by is just kind of extra on there. Order by is just a way that you can kind of sort by a column. Descending means that you start with something closer to Z or a bigger number, and then go towards A or towards a smaller number. Ascending is the opposite. That would be ASC, and it works in the opposite direction. So that's our query. Excellent. That's probably one of the trickier queries that we had to do, but it's all based off of this. The next one is we want to find stuff that's within a specific range. Let's say year. Let's say that we're working with year in this case. So let's say, we'll say select star from top 5,000. We start with this query pretty much always. Whenever we're doing a read command, select star from the table you want to work with. And now we're going to add in the other pieces. So we're going to be constrained off of rows, which means we use which clause. Which command?
Where?
Where, because we only want to return certain rows. So we use where. But where what? So it's where year is in some capacity.
Is greater than. I mean, you can use mathematical functions, can't you?
Sure. So you can say where year is greater than or equal to, you know, let's say we're wanting to do best songs of the, let's pick a decade for me.
80s.
60s.
I heard the
60s.
80s first. So well, the 1860s, no, we don't have any data from there, unfortunately. 1980, and the year is less than 1990. And year is less than 1990. And this totally works. This is a perfectly valid way to do it. I'm going to show you some other ways to do it just so that you see it and you can recognize it, but this totally works. You can totally use this. In fact, let's copy and paste it in there.
Can you go over the limit, MySQL limit call? Because that's what we used, and I got information back, but just not.
So what limit will do is it looks at how many rows you get back, and then it just takes the first X number of them. So if I said like limit 2, it would just be like, yeah, here's the first 2 entries that meet this criteria.
Oh, gotcha.
So let's run that.
But
As you
doesn't
can see, we just get 2 entries. There's a lot more stuff that meets this criteria. And so you're just going to get limit a number back.
So there, Steven was working on this and he got it to work, but isn't limit takes in 2 arguments, like how many you want to see and out of how many? So it's like,
Well,
you can see 10 and then.
Yeah. Well, it's out of whatever. Now you can use offset, like so. And then that will get you the next 2 after that. So if you want to, for example, do the first 10, it would look like limit 10, offset 0. And then if you wanted to do the 10 after that, you would do offset 10. And then if you wanted to do the 10 after that, you would do offset 20, so that you could just page through them.
Yeah.
Like you were clicking next on Google search results. That's how you would do that. And that's you use limit and offset to do that.
we just use limit and an array, and you can do the same thing? Is there something that would get a different result from that we shouldn't use that?
That seems fine. I've never used it that way, but I don't know all the SQL out there, so it's probably fine. That's just the way that I've paged through it before. But limit is about limiting the results you get back from this query in some way. So you could ask for the first 10, versus if you want to get all of this back, you want everything that matches that criteria. How, if you happen to know sequentially how it works, then you can manipulate that. But for example, with position, where you're guaranteed that there's 1 in each spot, you can do that. But if you're doing something like year, where you're not sure how many are going to be in each year, you're not going to get the correct number.
Because what I was finding is you can put question marks in any query statement that you make for any value, and then you can create a table with square brackets instead of curly brackets and sequentially put in any variable that you want in place of those question marks.
Yes. So in that case, we would do question mark, and then we would have, 1980, 1989, if we were writing it in Node, for example. But there's another command I want to show that you can use as well. So if I flip, so let's try between, let's say we're a year between 1980 and 1989 is another way that you'll see it written, where people use the between. Keyword. And I'm curious about this. Let's see what happens if we flip the numbers. I want to see if it's smart enough to figure that out. Nope, didn't think so. So you always want to have your smaller number first in that case. So either the greater than or less than will work, and between will work as well. Cool. Next, we had a query which searches for a specific song in the top 5,000 and returns data for it. Let's go ahead and say select star from top 5,000 as our starting. And then what else do I add to this?
Where song equals whatever song you're looking for.
Song equals hey, yeah. I think it's in there. Let's find out. And I think I'm even spelling it correctly. That's always a stretch. Yep, there it is. Number 45. Cool. So we have the template we want to work with for each one of these. The next thing we get to ask ourselves is, what can the user input? What can the user input? For some of these, the user doesn't really put much in here. Like, how many, give me a list for all the people who appear more than once. That's not really going to be asking for user input. Maybe like, hey, 2 times, 3 times, etc. And you can increase the limit, versus ones which are sung by a specific artist, things in a range, a specific song. Those are more clearly broken up into, hey, these have user input. So you can do it in one of 2 ways. You can either say, I'm going to hard code it to be song specifically, and I'm just going to put the question mark where the value is. Or you can make it a little bit more generic. So let's select from this, and then the array would look like, hey, yeah. Or you can make it a little bit more generic where you say question mark, and then you would put in here instead an object, song, hey, yeah. So you could use the question mark in one of 2 different ways, either just for the value or for the column and the value. If you want to do the column and the value, you're going to pass in an object. If you just want to do the value, you pass in a string. And it's smart enough to figure that out. If we have 2 entries right here, it's a little bit easier to do that with just a straight up value, where you would say something like, okay, the first question mark is 1980, and the second question mark is 1989. And then for artist being Queen, you've got a few more question marks. I just want to take a brief look at the code to see how we can structure this. This is the solved version. It'll be pushed up in just a second. So we've got the host. Let's go ahead and close out that for now. We do our default connection. We connect, and then we call run search. Run search is the beginning node of our application. So from run search, if we were reading this, we might say like, okay, run search, it's at the beginning. Let's draw out a circle for it. It's our first node, as it were. From run search, where can I go? Well, let's close up the inquirer questions and just look at them. We see artist search, multi-search, range search, song search, or end. So with end, it can just leave. And then we've got 1, 2, 3, 4 different ones. And they're basically going to follow the same format, make a SQL query, print out the result, loop back to the menu. And this is often a good way to structure your inquirer programs, where you just think about a function per set of questions to the user. So it's easy to say, oh, how do I get from one to another? Well, just it gets called in here somewhere. And then almost all of these just loop back afterwards. Cool. So let's take a look at what they actually do. The first one is just, which one do you want to do? And then based off of that answer, we call one of the functions. Let's start out with artist search. Inside of artist search, we ask which artist they want to use. So the thing is going to be part of answer.artist. Our query is select from these where the artist is whatever the user typed in. And then this is just to print it all out. You could have said console.table res here as well, and it would work just fine. Any questions on artist search?
So I have a little bit of different of syntax. After the dot then, I just do let query equal connection query with the MySQL query in there.
So did you do it like let query where, and then you just say like artist equals
No, it's like
plus answer.artist or something?
No, so it's like let query equals and then connection dot query with the select in there. So just like moving 71, yeah, the first part of 71 up. I mean, it works, but is that
That's
smart?
fine.
Yeah.
There's no,
Yeah.
either way is completely fine. This one's just nice because it's kind of removed from everything else going on in here. So it's easy to just look at by itself. But there's absolutely nothing wrong with having just written it in line.
Okay. Thank you.
But great question. Other questions?
Can we use backtips on the let query?
Sure. You could do it like this. And but one of the reasons that we leave this as a question mark, you could say where artist equals and then just put in like answer.artist. And the reason that we don't like to do this is because of SQL injections. Because if you're not set up properly, answer.artist, what if answer.artist is right?
So, actually, I was doing like putting quotes between dollar signs, not like making a.
Yeah, you could do that as fine. But one of the reasons, that's a question that might come up. Couldn't we just build this string ourselves? And the reason is because sometimes you'll see stuff like this, and the MySQL framework is going to basically look for things like that and say, hey, are we going to let something like that happen? Because what it actually does is it sort of escapes everything that you give it so that it's not literally written like this. It's written like a value to help prevent you from this, which would just be like where artist equals queen, drop database like this. So just so you know, this is called a SQL injection. And there's a very famous XKCD comic about it. How many of y'all have heard of XKCD? All right. Well, it's a web comic. It has a lot of stick figures. The art kind of looks like this. It's popular among programmers. And so if you just say XKCD little Bobby tables, there's a very famous interest of this. So it's, hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way, did you really name your son Robert Drop Table Students? Dash dash. Oh yes, little Bobby Tables we call him. Well, we lost this year's student records. I hope you're happy, and I hope you've learned to sanitize your database inputs. So when you're building SQL queries that are just the result, that just get put in there and arbitrarily run, people can do this. This has happened in real life apps. The Super Meat Boy, a video game, leaderboards got basically hacked this way because they just were like, hey, we'll just make a direct call to the database in our game. And people just were like, okay, I guess these leaderboards don't work anymore. So it can cause real world damage out there. And that's not even to mention some of the more serious use cases like medical records, financial records that are out there as well. So be aware of SQL injections and try and avoid them where possible. Fortunately, they're pretty easily mitigated by using frameworks and sanitizing your inputs and escaping them properly. But there can be a lot of real world damage out there. if you're not careful. Fortunately, using a framework like this, using the question marks handles a lot of that for you. If you're ever curious about that, you can let me know. I'm also going to post some links into some resources that go way too in-depth for this class, but they might be useful as your career progresses. Cool. Let's go look at multi-search. Multi-search is pretty direct. The only thing that we're going to have here be different here is the group by and the having count greater than 1. No user inputs, no question marks. We're feeling pretty good. We'll change that back. Next, for range search, on prompt here, we have a validate function. The validate function is going to take the value that the user entered and run some tests against it and then return if it's true or false. Mostly this is done to do things like check if like the username or the password meets length requirements, are pretty static things. You don't use validation to check if the username is available. That would be a call to the database. This is just used to see if, hey, this is a potential valid username, someone could have this. But it's not going to do things like check, hey, does someone else have this? It's things that you can do just by looking in it by itself. So if you can just look at the username and automatically tell, does this qualify? The same way that you could look at something and say, hey, is this a phone number? Does it have the right number of numbers? Maybe 10 or 11 if you're working with international numbers, or 12, because they have a lot of country codes out there. Then you might have that in here, but you're not going to have it where you're checking for things like uniqueness, for example. Is not something you would check in the validation here in Inquirer. You can do that later. We'll take a look at that when we get to doing it with certain SQL queries and certain technologies, but for Inquirer, it's going to be pretty direct. And then you can see where position between question mark and question mark. If we were being really careful, we would even check to make sure that answer.start and answer.end are in the correct order. Otherwise, we could flip them if we were being really user-friendly. And then we just, again, console.log them out. This is basically a homespun version of console.table. So this helps clear that up a little bit. Song search, again, we see the question mark and we see the object where it's the column for the key, and then the value is the row value. Cool. Any questions over this activity?
That between function, so you can have that be the position we were talking about with using limit, but instead of putting how many you want to see and where you want to start, that's just 2 inputs of where do you want to start, where do you want to end?
Correct.
Cool.
So if you put 1 and 11, you might expect to get 10, but if it's years, you don't know how many entries you're going to get. If you use limit, you know exactly how many rows you're getting back at most. You might not get any if nothing matches the conditions, but you'll have at most 10 or however many you set in the limit. Right on. So this is pretty cool, but we'd like to work with some additional data. There's limited insights that you can draw from a single data source. So what we're going to do is introduce another set of data and start asking some questions from it. So we're going to go ahead and open up 14 tables. If you look in the unsolved folder, you'll see the top songs and top 1,000 songs again. And there's a new entry here called top albums. Pretty similar. The only difference is that instead of the song title, we've replaced that with the album name. And you can see that the scores have changed up a little bit, with Sgt. Pepper's Lonely Hearts Club Band taking the top spot, followed by Thriller, then the Beatles again at Abbey Road, and then Saturday Night Fever, Dark Side of the Moon. Then we finally get to U2 and then the Beatles again. So the Beatles are already getting are showing up 3 times in the top 10 album. Pretty influential. So, what are we going to do? Well, you're going to start out by making a schema table for this. It's going to be very similar to the last one you made. Very similar. In fact, it might only have one column name difference. And it might just be a different table name, and one column name will have to change. Nevertheless, we're going to ask you to make it from that data. Then you're going to have to import that data, which will be pretty good. And after that, we want you to ask the following questions. We want you to find the years where a band had both a top album and a top song. And so one in the top 5,000 albums and one in the top 5,000 songs. Now, is there going to be correlation to that? Are those songs probably on those albums? Yes, but not necessarily. So in 1974, Queen had an album, Sheer Heart Attack, and a song, Killer Queen, both there. So the album position was 907. You could also throw in the song position if you want. In 1976, they actually have the song Bohemian Rhapsody and Somebody to Love, both off of the album A Day at the Races, or both and A Day at the Races because they match. In 1977, We Are the Champions and News of the World and We Will Rock You off of the album Jazz. Bicycle Race off of the album Jazz. They're not necessarily guaranteed to be off of that album because it's possible to release a single and an album in the same year and then have them both do super well. But it's unlikely. But nevertheless, it's not guaranteed. So our question specifically is years where they had both a top song and a top album. What were the top songs and the top albums that year? So you might have overlap. You might see the same album appear multiple times. You might see the same song appear multiple times. Just depends. Cool. So that's what we're going to work on next. So first of all, let's sort of build the tasks for this. Create the table. Import the data into the table. Write the SQL query. And then add it to our node program if you have time at the end. I would focus much more on the first 3 than the last one. So make sure that you do it in this order. We're more concerned at this point with you getting the query correct than necessarily making node work with it correctly using Inquirer. We'll definitely have a chance to work with that more in the future, but we want you to understand the underlying queries. We're going to work on this for about 60 minutes. We're going to review it as the last thing we do in class today. And then during office hours, we'll be able to answer any questions that you might have at that point. And that'll be it for Monday.
I have a quick question. So are we adding this table that we're creating to the top 5,000 database we already have created?
Yes.
Okay.
Yes, you're adding it to the database you already have.
Awesome. Thank you.
All right. With that said, good luck. If you have questions, let us know. We'll be rotating through the rooms. So let us know if you have questions. Good luck. Alrighty, folks. Looks like a number of us are still coming back. We're going to go ahead and take a look at the solved version of this, and then we'll have office hours for today where you could ask any questions about any of this stuff if you want to know more about SQL or other different things. We'd be happy to answer that. Tomorrow, we're going to start talking about, hey, can we start integrating this with web servers again, with building views and building views dynamically, and that should be pretty fun. So look forward to that. But let's go ahead and take a look at this. So let's take a look at that schema. So we're just going to add it to the schema we already had. So we dropped the database, we created the database, we used the database. This is create table, top 5,000, and then our create table, top underscore albums. You could have named it something else as long as you're consistent about it. It's fine. Has pretty much the exact same structure, except song is album. Pretty much just copy paste and song becomes album. And then you can check that you've correctly imported it using the same import process. So what I would do is just copy this into my workbench, make sure that it works. Then I would take that out so I don't accidentally run it again. I'm going to refresh the page so I can see all the schema I need. There's top albums, right click, table data, import wizard, move over to the piece I want, etc., etc. Now, if you don't have the correct number of columns that it expects, sometimes it'll cause problems. Or if your columns are in the wrong order and the data types don't match up. For example, if you try and say, hey, I would like to put the total sales first because the first item in our list is after the position is a song title, it's going to throw errors. It's going to potentially cause issues. So it's best to make sure that the two things align as closely as possible. So I click open. It gives me a quick preview that says, after I click next, it'll say, hey, did each one of these match up with what you expect? You can just drop this down further and then click next. It imports, etc. Now, while it's doing that, let's talk about the query that we need to do. So what we need is a way to say, hey, this band had a pretty good year. They had a top song and a top album in the same year. And we want to make this as easy on it as possible. So we don't want it to make it spend a bunch of time joining stuff that it's not going to use ultimately. Let me make sure I've got my notes up correctly. Awesome. So first of all, what two tables are we going to be using? That's where we always start the process whenever we're thinking about, hey, I need to get data, is what tables are involved. So what tables are involved here?
Top songs and the top albums.
Yeah, pretty directly, top 5,000. And then we'll just say join top albums. What kind of join should it be?
Inner.
Inner, because we only want it if they had both a great album that year and a great song that year. Whenever you hear that and relationship, then you're going to have an inner join. But it doesn't know the criteria it should use. What should the criteria be? How does it join these pieces of information together?
Artist name.
Yeah, so we could join on the artist name. I'm going to join on top 5,000 dot artist is equal to top albums dot artist. Is that enough?
And then also year.
And we want to make sure that the year is the same as well. And top 5,000 that year is equal to top albums that year. Now this would be enough. We'll write, and there's my JavaScript is showing. And since this is hard to read, it's good to just sort of break this up into maybe a couple of different lines. Cool. So another thing that we want to do is, if we want to look, so this will give us every artist that has one at the same time. If I want to limit it to just a specific artist, how would I do that?
You would do a where, and then the like top out with the artist equals.
Artist equals, let's say the Beatles. We know that there's quite a few on there. Should I do anything else? Well, do I need to do anything else? Yeah, that's correct. I don't need to, but there's a thing I can add that will help me, and I'll talk about why. And top 5,000 dot artist equals the Beatles. And we'll talk about the order that we do this. So when we do these select statements, the where, even though it's written afterward, happens before in the process. We get the tables, and then we're going to filter down the tables to our relevant rows. Which means if I get rid of everything that's not the Beatles, it's going to compare even less rows to each other. So if I think of this as a number of rows that I have, let's say I've got, I don't know, whole bunch of rows just going on here, dot, 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 etc. And there's just more and more and more. If I've got 1,000 rows in my top albums.art or top albums side, and 1,000 in my top 5,000 side, how many comparisons do I need to make? If I've got 1,000
5,000 times 1,000.
Yeah, it'd be 1,000 times 1,000, which is, that's, you know, 1,000,000 comparisons. That's a lot of comparisons. In fact, it's always going to be whatever that is times that number. So just if I just have 2 of these and then I suddenly just have 3 of those, then that's still 1,000 extra comparisons than I need. So we have these M and N. So if we filter out just M, that's better, because now I've dropped one of these to say like 7, but it's still getting multiple, or let's even say it's the Beatles, it's probably closer to like 100 or something like that, but that's still a 10-fold increase. And I just did 1,000 comparisons to do that. Then this one, I do 1,000 comparisons, and let's say that I get, I don't know, let's say that I also get 100. So currently I've spent a budget of 2,000 comparisons. And then I've got 100 times 100, which is, I think that works out to be 10,000 comparisons still, which is about 1.2% the number of comparisons I need to do now when trying to combine them. So by adding this where clause, I've well, even more than decimated. I've gotten rid of like almost 99% of the work of comparing the thing. So you always want to include these extra where clauses. If we just did one of those, so then that would be 100 times 1,000, which would give us 100,000. We only do, so that'd be 101,000 comparisons versus 12,000 comparisons. So that's why we have this second part, because you're going to save yourself about 90,000 comparisons. Again, almost about 90%. So a big thing with databases is not just writing correct queries, but writing efficient queries. That's pretty much all I'm going to say on that. But the more you can learn about that and the more you can be restrictive with your where clauses up front, the better, because you're going to have to just operate on less data. And that was just kind of a mathy explanation of why that is. Now let's look at the code. The code isn't going to be that different from what we've seen before. If we scroll down to the only have is that we've got question marks for top albums.artist and top 5,000.artist. And you'll notice we put the same answer in each. And we did that to reduce the number of comparisons that we would have to make so that it could run faster. In fact, let's go ahead back to our SQL. And let's see if we can compare the times here. So we'll put this in here. I'm going to just say, hey, what if we don't? So what's the time if we're just joining all of these together? We start the query, and it takes a little bit of time for it to run. Usually it would tell me how long that took. So the duration was about 1.295 seconds for the fetch time, 0.077. Let's try that again with just one of the where clauses in place. I gotta get rid of that spare one. So with just the where clauses in place, you see that it cuts down the time in half effectively at that point. But that makes sense. We're just looking for the Beatles. And then let's cut that down again. You'll also notice that the fetch time went substantially further down, but that's because we're working with some of the same data. So let's take the whole thing, run it again, and you'll see that it again decreases substantially from 0.029 seconds to 0.006. So from 29 milliseconds to 6 milliseconds. And that's just with our small data set. That's just with thousands of rows. It's not uncommon for companies to have millions, billions, or even trillions of rows. Granted, you're probably not going to fit trillions of rows on your dev machine. You're probably going to be working with the thousands to millions at most on your local computer, at least. So that's just to point out to you how much the data differences can scale. So if you've got 1,000 people talking to the database, you're going to, or 1,000 people making this same request. This one is going to happen in 30 seconds. They'll all be served, which doesn't matter too bad if you're the first one, but if you're number 30 and you're all hitting the service at the same time, having to wait 29 seconds for all the other ones to finish ahead of you doesn't feel great. Versus this one, everyone's done after 6 seconds, which is still long, but it's not as big of a deal. There's a substantial feeling difference between the two. So performance, believe it or not, part of the user experience. All right, I think I've prattled long enough about database performance for today. Tomorrow we're going to look at connecting our databases back up to web servers and actually using that data in our front ends. So our front ends are going to give us information that is based off of content from the database, which will be pretty exciting. We'll dive into that and we'll start looking at how we can start organizing these pieces together as our projects are getting bigger and bigger and encompassing more parts of the stack. But we have all those basics now. Now, before we start switching it over for office hours, are there any questions?
What about using? Would you apply that whenever the column names are the same and it's like to consolidate, or when would you use that?
Using? Do you have an example handy?
I had one up.
Yeah. You mostly use using to help you with naming stuff. It's kind of like as, but for some other things. So that's why I'm just kind of curious as to what you mean with using. Like you can use using to build subqueries to make other lists in there. So you could say like, instead of saying all of this, join these two together, you could make a subquery inside of one of those tables, and then you could use using to make that subquery easier to reference. Or you could use it for joins and some other stuff as well. I haven't used that part a ton, I'll be honest. But if you want to know more about it, you can just ask me during office hours and we can look at it together. Cool. Other questions? Or it can be more of a substitute for on, but as well. All right. Well, if there's no more questions, we're going to go ahead and call that class for the day. We're going to take a few minutes to shift gears into office hours. If you have questions, we'll start out by just diving into using really quick, and then we will proceed from there with any other questions. Cool. We'll see you in 2 to 3 minutes.
Hey, Matt, were you able to get that SQL search to run in Node?
No, it comes back with that I have an ambiguous where clause.
Okay.
So everything, I mean, I put it in exactly how I had it in there.